All right, welcome to assignment day 11's YouTube video. We're going to go through this and explain these. Remember, if you're having trouble, please see any of us before the test. The first one, write the slope-intercept form of the equation of each line. So when we're doing slope-intercept form, remember we need basically the slope and the y-intercept. So looking at my graph, I always want to pick any points they give me nice and solid, and I'm looking at my grid lines. I've got this one here as my y-intercept of -4, and my slope, if I actually go between these 2 points, excuse me, I should be able to count rise over run. So up 1, 2, 3, 4, over 1, 2, 3. My slope for this one is going to be rise over run 4/3. So I can simply, since I have all the information I need, go to y equals 4/3 x minus 4. And that's what we call slope-intercept form. All right, moving on to number 2. You may get a little confused about the slope-intercept form, but remember, vertical and horizontal lines, we want to be able to go quickly and not worry about forms. We want to understand that they're unique. So looking at this line, I have many ordered pairs on this line. A lot of ordered pairs all along this line. What is staying constant everywhere? They all have a y value of -1. So that, in any form, I just write y equals -1, and that's my horizontal line. Likewise, when I'm looking down here at number 3, the directions do change to standard form, but with vertical and horizontal lines, we look at those constant values. Out of all of these ordered pairs, everywhere on this line, we have an x value at -4. So that is the equation of the line, x equals -4. I really do think that's the best way to think about those. Really connect the math, because if you start going into point slope form, slope-intercept form, you might run into a little bit of trouble. Okay? Now in this one here, we do need to get into standard form, and I think the best way might be to actually start with slope-intercept form. So the slope here is, all right, let's see, we're going up 1 over 2, up 1 over 2, up 1, that doesn't quite work. So I'm going to try to pick some other points that work out, really well. That one looked like it worked at first, but it didn't. So maybe this point right here and that point right there are crossing at nice, neat spots. Or I could go, okay, so ready? Up 1, 2, 3, over 1, 2, 3, 4, 5. So it looks like my slope is going to be a rise of 3 and a run of 5, and I am going in a negative direction for the run, so I'm going to make this a -3/5. And now I have x because of my slope-intercept form, and I'm going to add 1 because that's the y-intercept of this problem. You could start at any point and use that slope, but then you would get to slope-intercept form quickly. Okay, so here we have, try to fix my pen here, sorry. Okay, here we have in slope-intercept form something that needs to go to standard form. So what we're going to do is add 3/5 x to both sides. So now on the left I'll have 3/5 x positive plus y equals 1. And for this to actually be into standard form, I can't have fractions here, here, or here. And I'm good here, but I got to get rid of the fraction. So what I'm going to do is I'm going to go and I'm going to multiply here everything. Multiply this side. Whoops, missed it there, sorry. By 5, we'll distribute that through, and then we multiply this side by 5. I'm still getting better with the pen. Have patience with us, please. All right, so these 5's cancel here, so you're going to have just 3x. And then going through to the y, we'll have 3x plus 5y. And then on the right side, we will have 5. Did I get that? Yeah, looks good. All right, moving along. Gotta get down here. There we go. Okay, so find the distance between each pair of points. So when it's given just like that, you're probably going to just do the distance formula, most of you. You could go graph it and do Pythagorean theorem. but I would think most of us are trained to just throw in the distance formula. So the distance formula we know is x2 minus x1 quantity squared. So what we're going to do is take our x values first here. Okay, so our x values are here and here, and then we're going to deal with our y values, which are there and there. And we're going to go through the Pythagorean theorem here. Sorry, the distance formula here. So x2, so that would be 0 minus 4 quantity squared plus negative 3. Now we're looking at those green points. Negative 3 minus 7 quantity squared. So working through the distance formula here, we have the square root of negative 4 squared. Any negative squared is going to be positive, so we're going to get 16. And we add to that, negative 3 minus 7, negative 10 squared is going to be a positive 100. So we have the square root of 116. Always want to check to simplify, and we can. There actually has a perfect square of 4 that goes into that. Square root of 4 times the square root of 29. So that's going to come out to final answer, simplified radical form of 2 root 29. Okay, another way, and I showed this in class, I can do this in green here, is the tower method to simplify a radical. So if you kind of struggle with simplifying radicals, watch this. If you take 116 and do this little upside down tower, if you divide by 2, you have yourself, what, 58 here? So I have 58, and then I'm going to try dividing by 2 again, and I'm going to get to 29. And at this point, what I want to do is I want to circle and cross off any pairs. So since I have a pair here, I circle and I cross that one off. That doesn't have a pair at all. So what we do is we take the circled numbers out front here, and that's where we're getting the 2. Anything untouched goes underneath. And I can help you with that if you want some more practice with other radicals. It's nice and convenient for the larger radicals. Okay, find the x and y intercepts of this graph by hand. Okay, so finding the x and y intercepts. So what we're going to do is go in alphabetical order here, and I'm going to work with the x-intercepts first. We call this the cover-up method. So the x-intercepts are the x values when y is 0. So basically this right here, we're not looking at, and we basically put in a 0 for y, it covers up, and we're left with 4x squared equals 16. So I'm going to try to write a little smaller. It's a little challenging. 4x squared equals 16. Divide both sides by 4. X squared equals 4. Not concerned anything to this point. I am concerned finishing here because a lot of kids forget to write it as plus or minus 2. And that's very important. This is a quadratic. There will be 2 x-intercepts. So in correct notation here, we have plus or minus 2, comma 0 in ordered pair form. Or you could separate them and write them both. Okay. Likewise, if we don't look at the 4x squared, for the y-intercept, or we essentially plug in a 0 for x, we would get 3y equals 16. So when we divide by 3, we get y equals 16 thirds. If you're still not understanding why we won't accept that as an answer, it's because that's a horizontal line right there. We need your notation to be answering what the question asked, so it's going to be 0 equals 16 thirds in ordered pair form. And we are having fun. Okay, is negative 8,2 a solution to this equation? I don't know. Let's plug it in because solutions come out to true results. So basically we just take 2 times our x value of negative 8 minus 3. I think you guys get this concept, but what are we doing here is making sure that the algebra is working out the way it's supposed to with our correct order of operations. So looking here, 2 times negative 8, we're going to get negative 16. Negative 3, but you have to do the 2 squared first. So that's going to be minus 3 times 4, or minus 12. So what are we getting here? We're getting actually a negative 28 equals negative 52. And would we say that's true or false? Definitely not true. So is this right here a solution? We would say nope. Okay, to finish off this page, I'm going to end this video at this page so they don't get too long here. Write the slope-intercept form of the equation of the line described. So I have here a point that I want to write it through, and I'm going parallel to another line. So I have a point and I'm going parallel to this. The main thing we're getting out of this is that we know what the slope is here, okay? And that's the important part. We know the slope is 3/5. So we're going to use that slope of 3/5, and we're going to use this point because we're going parallel. So this will be y minus a -2 equals 3/5 times x minus a -5, and obviously those are turning into addition. So now the directions say slope-intercept form, so I'm going to distribute through, and I'm going to have y plus 2 equals 3/5 x plus, ooh, that's kind of nice. When it goes through, the 5s are going to cancel, and I'll just have 3. So when I subtract 2 to both sides here, I have y equals 3/5 x plus 1. And that would be the equation of the line that goes through this point, but it's parallel to this line here. All right, and the last one, number 9 on this sheet, we want to go parallel to y equals -5. So here's what has to happen. We need to start having fireworks that go off when we're looking at, whoops, sorry. Let me undo that. My first undo there. Nice. Okay, hit the wrong button there. We need to have fireworks going off when we see this right here. What does that tell you? Well, hopefully it tells you that this is a horizontal line. All right, horizontal lines, get back on track here. Horizontal lines are y equals, so we're going parallel to that. So all that just told me is there's another line that's parallel to that. Those are supposed to be horizontal, sorry about that. But this one here is parallel to this one. And I know that this point is on that line, okay? So what I know is that 2, -1 is on here. And what other ordered pairs will be on here? Well, they're all going to have the exact same y value because we're parallel to that one. So this is going to be simply y equals -1. And again, you want to keep thinking about how to solve these ones, how to go through these problems with the horizontal and vertical lines.